Good morning, guys. I'm really sorry about this morning. There's some technical issue. I tested before a few days ago. It worked well, but today I tried to connect a few devices with some Bluetooth, and that might mess me up with my audio. But anyhow, I think now we're gonna switch to the online teaching, and so I'm gonna go through some sort of some change or update, so that I think we should be good together. So let's work together and make this thing work. All right. So regarding to the class info, we no longer meet in the new building, room 216, but we're gonna do an online or streaming. Okay, so check Moodle every meeting before you come to or before you attend the live streaming. Check the URL and announcement. So basically, I would try to attempt and do the class using a live stream so that we can have more interactive. You can ask some question by chatting something, and regarding if you want to meet me and having some question regarding any question about the class, also anything that you want to talk to me, the best time I would allocate my office hour from Monday to Friday, 1:30 to 3:30. If you want to meet me in person, send me with me, send me email, or you can text me, or you can Skype me. So, I think right now, I think we should follow the recommendation for social distance. So I think the best way maybe just do Skype. We can do video Skyping. Okay. Also, normally I don't give my personal cell phone number, but you can take it down. My cell phone number is 318-243-6597. It's on my PowerPoint here. But please text me before you call. Okay, because I don't pick up uh, the phone number that I don't know. Anyhow, so I think the best way to do Skype or sending email, or you can text me. But if you want to send me email, please using my Gmail at nibok@gmail.com. Um, I would change a little bit about the policy, and therefore it will alter the important dates. Okay, originally, I mean, if we have in-class meeting or classroom, I plan to have two exams, which is the midterm exam. Originally, I target on April 16, and then the final exam is on May 14th. However, I think I'm not sure the midterm or final exam would be the effective way to evaluate you. So I thought that with this online or streaming, we don't have face to face. So I want to get a feel of you in terms of the feedback, how you learn from the class through many more quizzes. Okay. So I thought about having 5 to 10 quizzes throughout the whole quarter. And if we don't resume face to face meeting, I would scrape off both exam, and then so to evaluate you in terms of your performance in the class, is gonna be so this is the original grading policy. Uh, Initially, I thought I'll allocate or budget like 5% for paper presentation. Those things, I think I would still keep your term paper presentation, but instead of you present in the class, I would like you to record your video and upload to YouTube for 5 to 10 minutes. The same type of presentation. You can do the PowerPoint. If you want to show PowerPoint overlay with your own video, you can do so. You can use OBS, or I'll send you the link of the OBS, which is the tools that I'm using to broadcast or record my video, that you can do a lot of cool stuff. In fact, OBS has been used for game casting and all those kind of things. Okay. The programming assignment, I will still remain or keep as is, like two programming assignment. Think this would help you to practice and gain experience in terms of programming. As I told you, all the classes, okay, you would not have opportunity to learn C and some sort of system programming, okay, especially interface to operating system. This is the only class that would give you opportunity to obtain the skill set or to build your resume so that you can be more marketable in near future when you start looking for the job. We would have two homework assignment. I keep 10%. However, the midterm and final exam, if we remain, or I think I'm pretty much leaning toward I'll scrape off all midterm and final exam into 5 to 10 quizzes. So the update or the revised grading policy is the following. Okay, the term paper presentation still 5%, and then that's the same. Two programming assignment 20%, and two homework assignment is 10%, and then the quiz, which is it could be weekly or bi-weekly, it's gonna be 5 to 10 quizzes. Okay, it's 65%. We have discussed among our faculty member, and I thought that I mean for online type of class, we should do some sort of testing or the feedback from you guys more often. That's why I decided to kind of combine both exam and then make it as the quiz. All right. So and then this is my update contact information. I think I'm giving you my cell phone number, so you can take a note, but don't post to anywhere. And then text me before you call me. Also, you can do Skype during my office hour, which is from 1:30 to 3:30. And then please use my Gmail instead of take email. Okay. So I think are we all clear on this? Okay. All right. Let's move forward. Okay. Um, Now, just to recap what we have started off last time, we'll talk about what is operating system. In fact, I think it's a system program that act or interface between user and computer. But the modern operating system is not only for user to computer, but also user to computer to user, or computer to computer. The main goal of operating system, in fact, is a system program that help manage resources. Okay, in a way that it would help you to execute user program, make solving problem in easier way, more convenient, safe, and secure. Okay, so the definition of system or operating system sometimes people call as resource allocators, okay, which in fact is implied that a system or software that has ability to manage and allocate resources in a fair, efficient, and secure. Sometimes it called control program that help control execution of user program and then operate on various devices. Okay, so in fact, it's just you can think about as a middleware or some layer in between the user and the device or thing that you want to use with regarding to computing. Okay, sometimes operating system also called kernel. Okay, which is a one program or system program that run all the time that help performing resource allocation and control program. Okay. Um, I think last time we also had shown you the historical aspect of operating system. An early system has no OS at all. Okay, it's just a hardware that, in fact, the software, there's no software, the actual software. It's just hardwired, between circuit to perform certain tasks. Okay, but later on the circuit start getting more complicated or sophisticated that allow the user to do some program. Early program, I mean, the user write in a close to the hardware language or the hardware code. Okay. But then, I mean, as you know, that sometimes when you write at the low level hardware code, it's if you change the hardware, then you're gonna have to rewrite the whole thing. So therefore, high level programming language has been introduced, okay, which is some sort a logical language or notation that you can describe your problem solving in a way that you can perform certain tasks, for example, computing, reading, writing, I mean the data to inform the storage, okay. So most computer language, okay, support those type of construct or syntax. And then once you have programming language, then you have either interpreter or compiler that would help translate high level programming language into machine code. So therefore you can start execute all those programs. But in fact, to execute the program, okay, early on you have only single mode or single user, single task. So there's no big deal. The OS in early version is more just like uh, job queue or queue up we call batch, okay, which is a mechanism to batching or to queue up the task or the job run one at a time. But later on, the operating system or people start thinking that hardware start getting more powerful, more sophisticated. So therefore, it has capability to run more than one job or one task. So time sharing, multi-user, multitasking start being introduced. Okay, one of the early operating system is known and the name is Multics, which is a collaboration between MIT and AT&T or Bell Labs, which is the company or the lab that where I came from, or before I came to Louisiana Tech, I worked for AT&T. Okay, and then that Multics, in fact, it kind of evolved into Unix later on in mid 70. Okay, and then I would say that Unix is somewhat a classic or modern operating system era start from there and then start evolve into more modern ones such as Windows, Mac OS, Linux, and Android or whatnot. Okay, so I think for today, most operating system I think has a similar concept from the Unix, which is one of the early modern operating system. Okay, so I think throughout the in this class we're gonna talk more various aspect or important aspect of operating system. I think we're gonna after we talk about introduction or historical aspect, then we're gonna get into the main feature or capability, which is process management. In fact, process management is a mechanism in operating system that allow program to execute. Essentially, I mean, why do you want to use computer? I think you want to execute some program in a way that it will solve your problem. Okay, and then after we talk about process management, that would include CPU scheduling. CPU scheduling is schedule various process to run on CPU or execute on certain I/O operation. Okay, and then we're gonna also touch upon how processes interact, and later on getting into multiple processes, how they work together in a way that we have to perform mutual exclusion or synchronization. Don't worry about this term. We're gonna get into later on in more detail. Okay, and then once we complete 3 or 4 chapter, which is gravitate toward process management or process things. Okay, then we're gonna go to the next important aspect of operating system, which is memory management, and then later on we're gonna conclude the class with uh, file management or storage management. Okay, so these 3 important aspects, which later on when I show you the diagram of for example a current operating system like Linux or Unix, you're gonna see those components which is represent quite significantly in operating system capability. Okay, so let's move on. I think last time we talked about an early operating system that running on mainframe. In fact, very first mainframe running one job at the time. But then later on, when hardware start being more capable or faster, then it has capability to run multiple tasks or multiple user. So in that case, from era from mainframe, then we move toward time sharing and then interactive computing. In fact, from when I was in high school toward um, college. Okay, I think I start with the era of interactive computing. So IBM PC start introduced by the time that I'm entering college, and then in that case it start with a terminal and the keyboard. Even though there's no mouse and all those graphic user interface until a few years later on. Okay, where when the IBM PC initially running on MS DOS. I'm not sure that you're old enough to heard about MS DOS, which is it looked like a terminal, single user and single task. But then later on, graphic user interface get introduced to Macintosh, and then later on to Microsoft Windows. Okay, so in interactive computing or time sharing system, it starts support multitasking, where CPU is multiplexed to run multiple job or multiple tasks simultaneously. So that some of the process will keep in memory, some of the process that may not being used, then the virtual memory kick in, so that it can swap process from CPU memory to the disk back and forth. Okay, and then in terms of interactive computing, another feature besides CPU scheduling or CPU multiplexing is support user interface such as CLI. CLI stand for command line interface. So those terminal that you can type command, it's called command line interface or the shell. And then you have a graphic user interface or GUI that you use mouse, graphic display windows, so then you can manipulate mouse, collapse, expand, and do different other things. Past 5 years, voice command or voice user interface start getting more popular, such as Siri, and Alexa, whatever Amazon Alexa. Okay, so those things start getting more into our life. Instead of using command, using mouse point and click, we can talk to computer. So then the computer can start perform tasks for us. Okay, and beside user interface, CPU multiplexing for time sharing or interactive computing, uh, we also have to have an ability to swap job in and out from memory to disk that we call virtual memory. Okay, so those we're gonna touch upon more detail in chapter 8 or chapter 9. Okay, and also most modern interactive computing also has some connectivity. So then you have online communication. You can do user to system, and then system browse to maybe another system, or you can send email, chatting, and all those. Okay, last but not least, for computer or interactive computer that has online capability, it's also um, have a way to access data or other node. Okay, in a way that I think that we call distributed computing. Okay, beside interactive computing in the early version is some of them are not online, but then most modern interactive computing is, I think I call pervasive computing, which is you can use anywhere anytime you want, therefore you have some sort of a real-time connectivities. Then with that era of, or the starting era of interactive computing, you have desktop or notebook system, which is it start from the desktop, which we call workstation. Okay, and then later on from the workstation it gets shrunk down into smaller form, so that it become personal computer. People can own a computer and can use it. I think right now you are an era of digital era. So everyone born as you have computer, notebook, tablet, or whatever smartphone in your hand. But for me, I'm an older guy, so I migrate into digital era. So I think therefore I have seen from computer is just like refrigerator now get shrunk down into something that it can fit in your hand. Okay, so most desktop or notebook computer operating system um, will deploy that allow people to use it as personal computer. And most personal computer you have I/O devices such as keyboard, mouse, display screen, and in fact various connectivity in more modern system like USB type of device such as printer, any other device. Its operating system must provide a friendly way or graphic user interface that help user conveniently use their computer and in more responsive way. Okay, it also has various operating systems that running on desktop or notebook systems such as Windows, Mac OS, Linux, Unix, Android, Chrome OS, or whatnot. Okay, so I think desktop or notebook probably you'll be most familiar with. I mean, I hope that everyone, I think you have your own computer, which is would be considered as your personal computer or desktop or notebook system. Then I think I want to show most of you guys probably have seen or used in your house. A lot of things in my house right now. My interest is in smart living, so I'm automate my cooling system, the lighting, the security with all these smart device. And I think some of the new system that interface to this smart system is voice control system. At home, I'm using them all. I have Siri that will connect to Apple Home. I also have Amazon Alexa that also connected to Alexa ecosystem or smart home ecosystem. I also getting into or bought whatever this Google smart device that I have not used a whole lot. Okay, but basically the idea of all this voice control is just listening to human voice. Okay, and then translate those voice into text to speech to text and then text to command. Essentially, there are a set of commands that this voice control system understood and perform certain tasks. Okay, so I would say that more and more we're gonna see more voice control that getting into our everyday life because it's just simply easy and start getting smarter and smarter. Early version I used Amazon Alexa for 4 or 5 years from the first version. Very first version, Alexa does not understand my accent very well. But I think nowadays, even though I speak some sort of half-broken kind of word, it still be able to figure it out what I want to do. So I think it's quite pretty cool nowadays. Um, Now we would look into various hardware, especially on the CPU side or in terms of multi-cores. Okay, um, early time when people want to speed up computers, okay, or CPU, then they would um, try to speed up through improve the clock speed. You probably have seen the clock speed from 1 gigahertz. I think from my early on to use computer, I think one of the first computer is probably not even gigahertz, not even maybe a quarter gigahertz. Okay, and then I see the evolution of starting from uh, sub gigahertz up until 1 gigahertz, 1.6 gigahertz CPU, all the way up to 3 or 4 gigahertz CPU. The issue of when you start clock your CPU to have higher gigahertz, okay, it transpires to the heat, okay, which we call thermal walls. Once your CPU or your hardware get heat up, okay, it make the hardware or the CPU is unreliable, okay. So I think if you want to read more, Google issue called thermal wall, okay, which is when you start clocking up your CPU, obviously it runs faster, but also it dissipate or generate more heat, which make the hardware unreliable. Okay, so from around 2005, 2006, people start seeing issue of clocking up too high speed, and therefore the technology pivot toward more component, more cost. So I think the solution of the trend that speed up computer is adding more CPU, adding more core. So you see that right now, Intel or AMD, you have up to 8 core or probably 16 cores. Most of you guys probably have like quad cores or dual core desktop computer. Okay. Um, but also beside CPU that people using speed up or running their application with multiple CPU or multiple cores. Now people start using GPU, okay, in order to map pixel processing into general computing, okay. Um, most operating system would run on CPU or the main cores, okay. But then when you start running your application on GPU, there's no such operating system on GPU. The way that CPU communicate GPU when you want to use both CPU and GPU to do computation together is through device driver or the runtime that you have an interface from the main kernel or operating system and then communicate through device driver or API toward using those devices such as GPU. Um, Another thing that I want to mention, because I mean you can see that why do we discuss about various hardware, because essentially operating system will manage all this hardware, so you have to know the situation, I mean the environment or the system that you're going to manage. If you have a single computer, single node, then you would have operating system to manage within that system, that to see to allocate CPU, allocate device, allocate file, allocate memory to work on. But nowadays, there are grand challenge problem, or there are some problem that require a better perform or a high performance computing we call parallel system. So with that, they put together a cluster of system or multiple CPU all together and put into single system. Logically, it's in a single system in a way that they connect different nodes all together and form larger computer. And if we look into how this parallel system or in another what we call supercomputers, okay, you can see in different type of architecture. Some of them has multiprocessor, some of them has multiprocessor, multi-cores. So within single system, if you open up the box or the case, you're gonna see multiple socket that they put multiple CPU there, and each CPU you have multi-core. So therefore, each of the system may consist of you can multiply number of CPU and number of cores there. For example, if one system you have one socket with quad cores, okay, then you would have one quad core system. But then if your system has two socket of CPU and you put two quad cores there, so in that case your parallel system has 8 cores there. And then if you have 4 socket, then you just multiply number of core, number of CPUs there. That's how they construct or build parallel system that can be scaled up. However, some of these architecture, you cannot randomly put like 100 socket there, because there's some issue of hardware design. For example, the data path that you connect between those sockets to the memory. So in therefore, you can have to design system that well managed and well oiled system. Another aspect of this parallel system, if we people look into how they connect together, if you have multiple socket of CPU connect in one system, for example, four socket or eight socket, those type of parallel system called tightly coupled system, where all the processor will share the same bank of memory. Okay, but however, some parallel system construct by the building block by put together multiple computer together and then connect them through network or some sort of exotic connectivity besides ethernet that some of the exotic or fast network fabric such as optical network. One of the most popular one called InfiniBand, which is very high bandwidth and low latency. So therefore, it can provide some sort of true high throughput when different systems want to communicate to each other. So let's take a look at the advantage of parallel system. Parallel system, which is sometimes you can consider as supercomputer, it will provide a capability of multiple more computing units that help increasing the throughput, provide resource sharing in a way that you can scale it up and then increase reliability in case that if one node die, you still have another node working. In case that one main node die, you may have backup node to work on as a fail-safe system, not fail-soft. Two big classification of a parallel system, okay, that if you can look into the book, parallel system architecture book, one called symmetric multiprocessor. Okay, so this is parallel system that consists of all CPU or all core are identical. Okay, so most parallel system would consist of symmetric multiprocessor. Due to the fact that if you have a various processor to put together as one single system, it's gonna be darn difficult to program them. Okay, what are the programming kind of model we're gonna use? What are the machine code? What compiler that would have capability to generate different machine code? So I think so. Some sort of most parallel system, I would say nowadays would be towards symmetric multiprocessor, but older system or parallel system has a symmetric multiprocessor in a way that you may have two type of processor putting into the same system. I think this one has some exception. There are some modern system that you have like Intel's main CPU core, and then within that system you may have one or more GPU cards attached. Those are exception because still it still run on the same. When they're put together, it still look as a symmetric multiprocessor in the larger scale, but within the box you may have heterogeneous computing, which means you have CPU work together with the GPUs. Now let's move on, I think this is the diagram that showing symmetric multiprocessor where you have all CPU are identical. Okay, and then this is if you guys are the fan or the have used Sony PlayStation 2 or PlayStation 3. Okay, some of those early PlayStation also implement or equipped with a asymmetric multiprocessor where it has a main cores which called PPEs. Okay, just like similar to Intel or AMD type of CPU, and then with the element connectivity bus or system bus, it also has a various cell BE processor, okay, which is different type of architecture, different type of machine code that support on SPE attached to the same system. So in this case, I think we call asymmetric multiprocessor that you have one main PPEs with L1 and L2 cache, and then attached to the system bus called element interconnection bus. And then with that you have 8 SPEs or different type of processor attached on the same bus. Okay. So you have to have a special software or middleware in order to program this, and programming aspect is quite difficult when you start program the system that has a various different type of CPUs. And here is the current Intel quad cores. One of the code name called Intel Sandwich CPU, which is essentially Intel quad core CPU. That you can see that there is a graphic processor that start integrate into the main Intel processor. In this case, you have quad core that all share the L3 cache. Okay, where also underneath it has the MMU or memory management system that connect through memory control I/O. So don't worry about this. I think I just kind of walk you through quickly on a various hardware so that you can start visualize the complexity and how operating system has to deal with different component, whether it has to consider allocation of different cores or graphic processor or different various I/O in order to manage various resource well. Here is an example of the current Apple CPU that A12 I think is deployed on the iPad. If you guys have the iPad Pro, I think the current iPad Pro is A12X, but then if you have iPad Air or regular iPad, the current one is running on A12 as well as the iPhone system. And to look into the hardware, you see that here you have the CPU 2 core, CPU 0 and CPU 1, and then each has L2 cache attached to each CPU. Okay, so you can see that slightly different architecture from the previous Intel Sandwich, which is, let me switch back. You can see that all 4 cores share on the same L3 cache. However, from A12, it got CPU 0 and CPU 1, which is the dual core. Each core has its own L2 cache. Look into more detail. You can see that the cache or the memory management, it probably will impose some issue or some sort of different mechanism or algorithm to manage how to bring the data from main memory through the cache and then to CPU. Okay. Again, don't worry about all this detail. All I want to show you is I want to deep dive and show you different level of the hardware and how moving data in and out and executing and perform different other things. Okay, you would be dictated by the underlying hardware architecture. Okay, by the way, Apple A12 also has built-in GPU 4 cores there. Okay, as you see on the right hand side. Now let's moving forward. Okay. Next, I think we already touched upon parallel system, and parallel system and cluster system is somewhat has good connectivity or relationship there. Most parallel system, okay, is built upon cluster system concept or architecture, where you cluster two or more nodes. Okay, essentially you can think about if you have two desktop and then you want to make two desktop as one unit logically that help compute in parallel. Okay, then you can connect two systems through connectivity, and then if you have some sort of middleware layer or API that allow you to create tasks on each node, and then has some API to allow you to send and receive data in between, and therefore you can create a parallel computing or a software system on the hardware system that support. So if you want to scale up, let's say if your two systems are not giving you enough capability, then you're gonna scale up to 3, 4, 5, 6, 7, 8. or maybe all the way up to 10,000 nodes. Okay, later on one of the slides I'm gonna show you the world fastest computers, okay, that you can log on to that website. Okay, also in terms of cluster system in enterprise computing, just like data center, sometimes instead of using them as parallel system, but they can use them as a server farm, where each of the server they can cluster them together and then provide the service to customer or to end user, either in round robin or whatever the load balancing kind of mechanism. So in terms of if we have to develop operating system to manage parallel system or cluster system, so in that case, besides CPU management or task management, memory management, you must also have the runtime operating system must have to have node management. Let's say you want to add one more node or a few more nodes, so you have to have an ability to manage, add, change, delete node. You also have to have a network management and task management. They all are equally important to the cluster system runtime and operating system. Also, load balancing. I mean, that also uh, most modern enterprise system, okay, consist of infrastructure such as cluster system or server farm that has load balancing feature or element in front, so that it can balance the load, okay, throughout the whole enterprise server farm to perform the task to suitable for your business, or to compute or used as high performance computing or supercomputing. This is architecture or simple architecture to show you a cluster system. A lot of time, most enterprise or cluster system would not expose all compute node or server farm nodes, okay, to end user. When you log in and or you want to use the cluster infrastructure, either is a private in the form of private cloud or public cloud. In fact, private or public cloud is just a layer of virtualization on the top of this hardware cluster system or cluster node. Basically, you would have a gateway, or we call primary head node, that would allow user to log in and start launching whatever the task or the job that they want to execute or perform. And then the head node would have load balancing or job distribution to distribute to appropriate node in a way that it may perhaps complete the task faster or improve resource utilization. Some of the criteria in which that the end user or the enterprise want to achieve, we have different criteria in order to achieve what we want. Sometimes you may want to run the job the fastest possible. Sometimes you may want to optimize or fully utilize your resource so that you can evenly distribute the workload to different nodes. Um, and this is some of the early version. I think this is 2003, 2004. Um, my background is in runtime operating system on cluster system or supercomputer or cluster. I have multiple um, federal grants from Department of Defense, Department of Energy to develop a runtime that will improve the reliability of this cluster system. Uh, in order to do my research, I have to build or create whatever experimental system. So instead of I have to have thousands of compute nodes, I could maybe create 4 or 5 nodes. So then I can validate our technique or algorithm, how to route, how to improve the reliability of the system. I think this system is no longer exists, and I still have a few whatever donate server from Intel in the lab if you guys want to see. Um, Here is one of the world fastest computer at Oak Ridge National Lab or Department of Energy. Okay, it's called Titan. Okay, I think this one is consists of 4,000 or 5,000 compute server, and each of the server consists of 22 cores, IBM Power 9 processor, which equivalent to like those Intel high-end processor, and each of the node consists of NVIDIA Tesla V100, which is if you want to equivalent to whatever your game, what the high-end game NVIDIA card, it's probably a commercial grade and enterprise grade version of 1080 um, whatever 1080 GPU or NVIDIA GPU card. Okay, and this one can clock the speed up to 200 petaflop, which is if you want to ballpark your desktop or your notebook is around 20 gigaflop. Okay, and then 1,000 gigaflop is equal to 1 teraflop, and then 1,000 teraflop, 1,000 teraflop. Okay, it will be equivalent to 1 petaflop. So you can start multiply some of those number, and then this is the peak performance is around 200 petaflop. Okay, and here is the latest list of world fastest computer that I mentioned. If you're curious to see who are the fastest, who is the king of the hill on the fastest computer, you can go to top500.org and then just scroll down and you can see the list. The list update twice a year. Okay, normally in November and then in June. Okay, November there is a big like conference or event called SC or supercomputing that would get update who is the fastest. The current fastest computer is no longer Titan, but also it's a computer that reside at the Oak Ridge National Lab called Summit. Okay, I'm not sure you know Oak Ridge National Lab. Oak Ridge National Lab has one of the prominent set of scientists that work on Department of Energy Research, including the nuclear weather forecasting, different other, the high-end research. And also they have a nuclear stockpile called, I think, Y12 areas that there's a military guard standing in front. The reason why I know Oak Ridge quite well, I used to work with Oak Ridge quite closely. In fact, I have the badge that I could go to Oak Ridge anytime, but I would not allow to enter that Y12 area because Y12 areas, you guys, if you guys remember a few years ago, one of those country that give up or dealing with the US government and give up their nuclear stockpile, not sure in Libyan or Iran. Okay, then the militaries carry those nuclear stockpile and then store in these Y12 areas. Okay, but I mean that I have nothing to do with those, and I'm not allowed to enter those areas. I'm more toward a whatever their computational science kind of department, which is involved with some of the supercomputer. If you look at the Summit, okay, Summit is based on similar architecture to Titan, which is IBM Power System. It consists of Power 9, which currently I think there are, let me see, how many nodes? I think you can just go to the website and deep dive into, but the total number of cores is 2,000,000 400,114 592 cores there. Okay, it quite significant. How do they manage all this? Okay, essentially you cannot just program all the cores in more random way. Most of computing paradigm or programming paradigm here is based on building block. So you start program the node, and then each node also maybe consists of one subtask that either they can communicate among each other. So essentially 2,000,000 cores it probably consists of 5,000 or 10,000 nodes there. So essentially, you just program the node and then make them work in a concert way. Okay. Um, other system I think you can read on. I think they are in the same sort of kind of paradigm or architecture that consists of this building block. Okay, essentially the reason why, I mean, I talk about this because one is I know it quite well. I also have some sort of professional experience on some of these systems. But to connect to operating system, beside uh, each node, normally we have an OS run on each node. I bet that some of these node would run natively like Linux kind of operating system, but also it has a middleware on the top that can allow the user to some sort of program they all together. So the programming, one of the programming paradigm or techniques called message passing or MPI, okay, that allow you to create tasks and then assign tasks to run on the node. And then it also enable the user through some API that can send and receive messages, among all these tasks. Okay, so I think that's beyond our this class. Okay, so I think we're gonna take offline. But essentially, if I ask you in the quiz, okay, that what are distinct feature from this cluster system, that if we gonna deploy operating system on this cluster system, what are the distinct features that required? Okay, beside a common feature such as CPU management, task management, memory management. So if you look into this, it consists of 4 or 5,000 nodes. So therefore, you must have like node management, network management, and then task management that working together. Okay, so I think this is the reason why I walk you through various hardware and then try to kind of um, give you some idea, visualize. I mean, what if you're gonna be the designer of operating system or pick operating system run on a certain type of hardware or architecture. Now, coming along, I think this is related to a previous cluster system on the node wise. Okay, some of those supercomputer, each node would normally currently equipped with a GPU. So essentially, in terms of how to use GPU to do computation, one of the technical term or industry term called GPU stand for graphic processor or general purpose graphic processing unit computing. Sometimes it's called heterogeneous computing. So essentially, you write a program on host, which is you see in the middle, and then you have an OS or operating system on the top. As you know, that operating system is a system software that allow user interface. So therefore, you have user interface, whether it's graphic or CLI, that you can write program and also launch some command on that OS on running on the host. So once program running on the host, okay, then you're gonna write a specific, like API or syntax in a way that allow you to use this GPU, which we call computing device, okay, through device driver. Okay, so I think one of the most popular GPU computing model and the tools called CUDA, CUDA. If you are interested in, you can Google and look more, which is an extension to C language. You're gonna run your program on the host or on operating system that running on the host, and then it automatically using the runtime to launch the subroutine or the function that running on compute device or GPU. That called kernel. By the way, this kernel, as I told you, is different than the kernel with operating system. The term kernel, when it refers to GPU computing, is a subroutine that running on compute device or GPU. Okay. I think one of the ideas for your term presentation. It could be some idea on GPU computing or GPU computing. So if any of you are interested in, you can send me email and reserve this topic, or multiple people can look into this as well. Um, Here this diagram showing um, the logical some sort of programming model for GPU. So the way you do the work is you will write a program called kernel or GPU program in kernel, and then the paradigm in which you will define a grid, okay, which is a three-dimensional type of data structure. So you can think about the grid is the platform where each grid has multiple block there, okay, and each block you have multiple threads, okay, that holding within the block. As you can see that, I mean, the metaphor or the paradigm giving you a three-dimensional kind of space that you can store the thread, okay, and thread can be think of the compute units, okay, or the subtasks that you want to perform. In fact, the thread, in fact, if you map to graphic card, it's just like pixel. So essentially, when you do GPU computing, if you want to do weather forecast model, or you want to do a stock market cap analysis, if you can map those problem specific into pixel processing, and then when you see pixel, okay, you can represent in 3D or three-dimensional space, okay. So essentially that's what it is to run or write program in GPU, map pixel processing into general purpose computing. Essentially a lot of problem represented by one-dimensional, two-dimensional, or three-dimensional array of data. For example, you may have image that you want to do image analysis. So in that case, you can subdivide image into a block or to grid in a way that you can do computing. And the way you do computing on GPU, you will instruct all GPU cores. Look into NVIDIA. I mean, essentially, N1080, whatever GPU card or cores, it has probably 375 or 512 cores. Okay, but I mean, with 512 cores, runtime also create a virtual cores that may be 2 times or 3 times more than those physical cores. So essentially, you're mapping all these the block, the grid, and the kernel paradigm into pixel processing. Essentially, don't worry. I think I just want to give you an idea or high level idea so that you can connect to the hardware and how this thing get managed with regarding to operating system. And by the way, as you see on the left hand side, those hosts is running on OS. So your OS or operating system running on the host, and then the host, okay, application that running on host will launch this kernel that will communicate to the GPU device, okay, through API, okay, which is from whatever the tools that provide by the vendors or by operating system, okay. um why don't we do this? Okay, I think we gone through an hour long. Let's do a quick pause, okay, maybe 5 minutes, and then after that I will continue on another 50 minutes so that we can complete our first lecture here. All right, okay, so guys, hang on and please come back, click on the next link that I'm gonna post on Moodle to complete today's lecture.